Use the properties of even and odd integers that are listed in example 4.3.3 to do exercises 33 and 34. When expressions of the form x minus r times x minus s are multiplied out, a quadratic polynomial is obtained. For instance, x minus 2 times x minus negative 7 equals x minus 2 times x plus 7, which equals x squared plus 5x minus 14. Part A says, what can be said about the coefficients of the polynomial obtained by multiplying out x minus r times x minus s when both r and s are odd integers? Okay, so here are the 7 rules from example 4.3.3 that we can use to answer part A. Now, if we multiply these two factors out, we end up getting x squared minus r plus s times x plus rs. Okay, so let's go through each of these. When both r and s are odd integers, then the coefficient in front of x is going to be an odd integer plus an odd integer, and the sum of any two odd integers are even. So this would be even, and r times s would be the product of two odd integers, and the product of any two odd integers is odd. So this would be the situation if r and s were both odd. Now, if r and s are both even, then r plus s is the sum of two even integers, and the sum of any two even integers are even. Similarly, the product of any two even integers is also even. So this would be the situation if both r and s were even integers. Now, when one of r and s is even and the other is odd, then the sum of an even plus an odd is odd. R times s would be an odd times an even, which would be an even. So this is the scenario when one of r and s is even and the other is odd. And that's the answer to part A. To answer part B says it follows from part A that x squared minus 1,253x plus 255 cannot be written as a product of two polynomials with integer coefficients. Explain why this is so. Well, the coefficient 1, 2, 5, 3 would be my r plus s. The only way the sum of two integers can be odd is if one of them is odd and one of them is even. But at the same time, r times s would also be odd, and there's only one way that the result of a multiplication would be odd, and that's if you took the product of two odd integers. So on one hand, we have two odd integers, but on the other hand, we have an odd integer and an even integer, and that's a contradiction. So that's why this polynomial does not factor over the integers. Thanks, everyone, and I'll see you in the next video.